Hi, everyone. My name is Demetrius Comes, and I work at GoDaddy as the VP of Engineering, leading our application services team. In previous lives, I've built video games, run large video game projects, even a few game studios, and worked as a security researcher. Currently for GoDaddy, my team is responsible for core technology at the company, as well as taking point to our move to AWS. This means my team is responsible for You messed up my slides. This means that my team is responsible for translating policy into actionable standards for our engineering teams and building orchestrating technologies that make those standards easy to achieve for all our engineering teams. This includes development of security standards as well as implementation of best practices. But before I really dig in, I want to take a moment to share one of my favorite quotes with you guys. I share this quote because the willpower that it takes to move a company the size of GoDaddy from our current on-prem solutions to AWS while all raising our already high bar in security, application architecture, operational readiness, and pushing through the enormous number of cultural changes that it takes a team with both intellect and the willpower to accomplish this. Luckily, I have such a team. Now I'd like to introduce one of my leaders that embodies both of these core leadership traits, Ed Abrams.
Thanks, Demetrius. Hi, I'm Ed Abrams, and I'm a Senior Director of Software at GoDaddy. I work with Demetrius on the application services team supporting the mission of helping with GoDaddy's move to the cloud and helping our teams make the transition to cloud-native architectures. We do this as smooth as possible and while accelerating our development cycle and ensuring that the practices of our teams are safe, efficient, and high quality. The teams I work with range from a product team taking a massive consumer product to Amazon DKS, to a security team creating new security checks to run against our AWS accounts, to an automation team that's helping to automate those checks across all of our GoDaddy accounts. One of these teams has developed an application encryption SDK, and that's going to be the focus of our talk today. One of my own favorite quotes that I like to think about is from someone you may have heard of before. It's easy for things to go great when everything's working right. But in Agile, in life, in the cloud, it's our attitude about failure that sets us apart. Designing in the right strategy for handling failure is not only part of a good engineering team and a good engineering strategy, but part of good companies and good leaders. I'd like you to take away 4 things from today's talk. The first thing is that developers need a simplified interface for managing encryption. Even something as simple as picking an algorithm and initializing it correctly can actually be tricky. The second thing is that an enterprise-scale solution for managing encryption should provide mechanisms not only for key rotation, but also for re-encryption of data on the fly. The third thing is that an enterprise-scale solution for managing encryption should provide you with blast radius reduction so that when a key is compromised, your data is the least exposed that it can be. And finally, the thing I'm most proud of, we're going to be open sourcing and announcing open sourcing of our incubator project, Asherah, which is our contribution to application encryption SDKs. Let me tell you a little bit about GoDaddy. GoDaddy powers the world's largest cloud platform dedicated to small, everyday entrepreneurs. With over 18 million customers and over 77 million domains under management, we handle more than 300,000 DNS requests per second. GoDaddy's made an increasing commitment to open source over the years. We strive to support several different foundations and products whose existence has made our world a better place and has delighted our customers. I won't read off all the contributions here individually, but it is the power of open source that has allowed GoDaddy to successfully drive its mission of empowering small, everyday entrepreneurs and making them successful with their digital presence products to manage their stories and manage their work online. We're in full swing with a whole bunch of products already out there, and with exciting new ones coming soon, like the one I'm going to talk about today. Our 3 focal areas have been Kubernetes, which helps drive the orchestration of our API services and products online, JavaScript, which is the foundation of our innovation in user interface design and user experience, and WordPress, which is the place where we manage millions of customer websites today.
So now you know a little bit about us, you know a little bit about GoDaddy, and you've seen our growing commitment to open source. I want to take you through a short trip through GoDaddy's recent history in hopes to provide you a context of what drove us to develop this application encryption SDK for key rotation, and how that journey encouraged us to open source this project. On March 28th, 2018, GoDaddy announced our partnership with AWS. It was a good day. This partnership will allow us to move the vast majority of our products and services to AWS. In what I call phase 0, our goal was really to determine why are we moving to the public cloud? What is our goals? How are we going to achieve those goals? And what are the constraints that we're unwilling to give up to get there? We came up with the following. In this model, we reinforce this with each team that we onboard. And their 3 goals are to ensure that they have faster speed of delivery of their features and their products to their customers. Increase the application performance for all our applications from every corner of the globe. And lastly, increase the reliability and availability of every product that we have from anywhere on the globe. But these goals need to be achieved within the context of some non-negotiable items: security, application architecture, operational readiness, budget, of course, and compliance and privacy. In order to measure these goals, we came up with an acronym, SPOC. No Star Trek fans? Okay, anyway. We use an acronym, we call it SPOC. It stands for speed, performance, availability, and quality. Each one of these letters has key performance metrics that we measure for every team. We then will to a dashboard, and that dashboard is on at least one television on every floor of every GoDaddy development location. It's amazing, by just simply putting up numbers, how they get better so much quicker by just having that transparent data sitting up on every location. Then this is all built on top of engineering best practices that provide our teams guidance on how to handle tech debt reduction, how to handle data encryption, and the services that we can provide. Our next phase, we needed to test these theories. So we started onboarding teams manually, one team at a time, to test the hypotheses that we just built. And also to test our landing zone. Our landing zone meaning, at the time, the infrastructure that we willed into reality for every team after they got onboarded to AWS to get closer to these new higher bar goals that we set for the company. After that, we did a quick retro and found that 4 things. Well, we found more than that, but the 4 things I want to talk about is we need to develop a starter list and start developing SDKs and services, because what we found is willing just the infrastructure into place wasn't enough. That we needed to use Service Catalog more, and not just to package AWS services so that our teams could use them with best practices willed into them, but also to take our own services and wrap them in Service Catalog products so that when we deployed them, this gave us a tangible unit of work that we could deploy to every team. This then allowed those teams, if something about the product that we were providing wasn't working for them, they could open up a pull request against our repo, make the change, and we could learn from their experience as much as they were learning from our experience. And this contribution model started to grow at GoDaddy. We also found that we made a decision early not to use VPC peering. Ultimately, this turned out to be the right job for GoDaddy, because as the API gateway approach worked well for layering security, providing an easy way for IAM role-based validation. This allowed one team to allow another team to call their APIs, and we could sign it with the SIG-v4 of the IAM role and be able to set up a layered, a bottom layer of a protection so that one team calling another team, we'd at least know where they were coming from. And lastly, we learned that every team that we onboarded had questions after we onboarded them, which started to build up a little bit of a concern around will we have enough resources to support the entire company once they get onboarded? More on that in a little bit. As we moved into phase 2, and took from that retro, we iterated our design and we iterated our landing zone. With the goal of phase 2 to find out if those iterations were moving us in the right direction. Thankfully, they were. However, we did learn a few things coming out of phase 2. Coming out of phase 2, we learned that we can't put together a set of rules of like, this is the things that you have to have done in order to go to production for GoDaddy, and then ask the teams before they are even onboarded to meet those goals. Problem with that is that the vast majority of our teams have never worked in AWS before. So they were still in the experimental stage. So we developed a stair-stepping type approach. We developed a concept of an experimental budget. And if you get an experimental budget, there's a much lower commitment from the company from a dollars per year perspective. However, there's also a lower commitment from you to meet what we call our cloud readiness review. It's very similar to Amazon's well-architected review. In fact, we started from that and expanded upon it. And then we can get a development budget, which has a little bit more, and you have to cross more of the T's and dot more of the I's in each one of those 5 categories that we talked about: security, compliance, application, architecture, that sort of thing. And then ultimately to production, where all the check marks have to be checked. That let us move into phase 3. The goal of phase 3 was to keep the company moving forward and continue to onboard teams while we went off and started building an onboarding portal, with the goal that once the team got their budget approved, that within 6 hours, the team could actually be working on AWS. This was and is a culture shift for us, because this is the first time we could have a software engineer of, say, an SDE 1 or 2 have an idea, and because of the experimental things that we talked about earlier, could go to their VP and sell him the idea. If he or she agreed with the idea, they could approve it, and no other approvals at the company has to happen, and that engineer can start to work 6 hours later. If that experiment is successful, they can go back and request a development budget. They have to first go off and find a product manager somewhere in the company that will back their idea and write the business case for it. If they do, they can get a full development team on board and get that funded and have development space at AWS. If you get past the development stage and you get sign off all the way up to the GM of your division for production, then you get to go to production. Each one of those stages, those 5 pillars that we talked about, the engineering rigor and the check marks that we do, increase as you go as well. But this is the first time at GoDaddy we actually empowered our youngest engineers to come up with ideas to move the company forward. This is how GoDaddy will innovate in the future. That then led us to our final phase. All those efforts and, quite honestly, the chipping in of folks from all over the company, because as we found from the previous phase, from phase 3, that as we onboarded more and more teams, we simply couldn't keep up with all the questions and couldn't keep up with all the new features that folks wanted. One of the things that we encouraged was for teams that if they were going to use the AWS service for the first time, they were going to open up the pull request against our service catalog repo, make the changes to it, submit the CloudFormation templates, and then we would roll it back for them. So between the efforts of my team and the efforts of all over the company, people chipping in, that allowed us to reach our goal of actually deploying the public cloud portal in April of this year, only 13 months after we originally started this journey. This internal source control, or internal open source model that GoDaddy uses allows us to pull knowledge from all over the company and pull resources without upsetting org models within the company. I'm going to take a little bit of a sidestep because this is the culmination of all that work. I call it, in the video game industry, I call this the money shot. This is the shot of our public cloud portal. This is the single pane of glass that all our teams go to find out if their budget's been approved, to go ahead and request a budget, to see their SPAC metrics, to see messages from us, to get a link to their security hub so they can see any security findings that they've had. The interesting part here is all this is built upon something we also plan on open sourcing in the relatively near future called UX Core 2. So the base core technology that we use for all our UI at GoDaddy, this was built on top of as well. So now you've seen how we got to GoDaddy, or how we got to AWS. You've seen how open source inspired us. But what was the trigger to actually kick off an application encryption SDK for key rotation? GoDaddy set a policy as we moved out to the public cloud to raise the bar on protecting our customer data. Any P*I data, PKI, PCI, or PII data must be both transparently data encrypted, meaning file system, database level encryption, that sort of thing, and application level encrypted, meaning that if you got a permission to get into that database and you did a select star from a table, you would get nothing back but encrypted data, at least the P*I data in that table. Sorry. So internally, we started to look at ways to ease our burden of developers, to orchestrate rotation of keys and re-encryption of the data with those keys. We were hoping to reduce the implementation scatter because, as we all know, if we give two engineering groups the same task, we're going to get two very different implementations, probably in two different languages. It was out of this desire that we kicked off this internal development project that we're announcing today that we're open sourcing. Our goals when we kicked this off was to democratize rotation of keys efficiently, democratize the technology to re-encrypt the data once those keys are rotated, provide an audit log for key access and data access, and this intrinsically also means that we're reducing the blast area of those keys so that you can have a hierarchical of keys that if any key got breached, maybe another system isn't exposed. Cross-language interoperability, because GoDaddy is a big fan of microservices, and we have 5 major languages used at the company. And lastly, strong API interfaces so that we can build defense in depth underneath the API as time goes on for known vulnerabilities in, say, memory management, as well as being able to increase for ones in the future. So now I'm actually going to turn it over to Ed, who's going to take you through what we're open sourcing and how you might use it.
Thanks, Demetrius.
Yep.
GoDaddy's incubator project, where we address these problems, is called Asherah. It's our application encryption SDK. And I say SDK instead of library because we're providing not only library elements for various languages, but also a plug-and-play infrastructure for key management and metadata for those keys, as well as a full stack and batteries included methodology where we're providing concrete, opinionated guidance and templates for standing up infrastructure pieces that back this and that can also be used to test performance and compliance. So let's take a quick peek at the architecture of the SDK. At the core, we base our SDK on the foundations of a key management service, which is our most sensitive management of our most sensitive master key. And this is an AWS service that we've plugged in, AWS Key Management Service, which fills that role, but you can plug and play your own if you have a different one that you want to use. We also need a metadata store that stores the metadata about our keys and our key hierarchy. And again, this is a plug-and-play interface where you can develop your own, but we base ours on the highly reliable, efficient, and highly available systems that Amazon provides, such as RDS and DynamoDB. On top of that layer, this foundation, we have, as Demetrius mentioned, a secure memory library. Here's where we can put protections as we invent them for the key cache, which is in memory. So in order to prevent the library SDK from always having to go access KMS, which is a highly latent call and can be expensive at scale, we have an internal cache of those keys, and those keys, as much as possible, need to be protected while they're in memory. So on top of that, we can build this secure memory caching layer, which is for efficiency as well as cost, and have that be relatively secure. And as we develop new and innovative ways to protect that memory, it goes in this layer of the secure memory library. At the top layer, you have the interfaces that the developer works with. An encryption API, which is encryption and decryption primitives, a key management service layer that lets you, again, configure and plug and play key management service of your choosing, a metadata store interface that, again, lets you configure and choose your own metadata store. And then a really cool thing that we actually think is nice, which is a crypto policy. The crypto policy gets instantiated with our encryption sessions, and it manages things like which encryption algorithm you want to use, how long a key will take to become stale and need to be rotated, and things like that. So I've mentioned a couple times hierarchical keys, and for us, there's two elements here. One is envelope encryption, which many of you know is the practice of encrypting a key next to the data that it encrypts so that those elements are stored together. But we also talked about a key hierarchy. So let me walk through this diagram with you to sort of give an explanation of our opinionated look at how to use a key hierarchy to limit the blast radius of a key compromise. So the master key, the one that's in your key management store, is the most sensitive key you've got, and it's used to encrypt another layer of keys. We call them service keys. Intuitively, we think of service keys as being keys that you apply to a particular service, like a web service, like an e-com or a profile service or some other kind of application API that you've got. We create a separate one of these service keys for each of those services. This means that if that key is ever exposed, only that service's data is even potentially exposed. And this provides a blast radius reduction of what it would mean if a particular key in that layer is exposed. But for each service, we have another layer of keys, which we call intermediate keys. Now, again, intuitively, and the way we like to think about it is that these keys are for your customers. So, for example, your e-com service, you may have 100 million, if you're lucky, different customers, and each one of those customers has his or her own key as well. Why is that useful? Again, blast radius reduction. If any particular customer's key is exposed, that doesn't necessarily mean that any other key for any other customer was exposed. And so the blast radius of any of those compromises is limited to one particular customer. Not only that, but now one particular customer for one particular service, because again, the fact that you have one particular customer key doesn't mean that you have that customer key for any of the other services, which, as you can see for the hierarchy, is actually a distinct key. At the bottom layer, you have your data rows, which are the PII or P star I information that's recorded in a database or some other persistent store. Those keys are generated from the customer key and stored with the data so that those individual data elements, again, one compromise of one wouldn't imply a compromise of any other. As I mentioned, we use some foundational AWS services that we want to call out specifically. AWS Key Management Service is what we use to protect our most sensitive key. It's got IAM protections and other account protections that we can offer here so that it's the least exposed key that we've got, and it's stored in a reliable, trusted, highly resilient, and available system that we can use as our core system. In addition, we use other AWS services, managed services for us that we know will always be there for us. For example, IAM access controls. With IAM access controls, we can highly regulate the access to KMS itself, as well as the access to our primary meta store and the data stores that we store the keys in for the data. When GoDaddy chose to open source Asherah, we had to consider the question of, were there other software products out there that might fill the same role for us? And again, thinking of our primary use cases, we want to focus really strongly on managing keys and key rotation, but not just key rotation, re-encryption of data on the fly as keys rotate, and then also this blast radius reduction concept. These two primary use cases are pretty unique to Asherah, and so even though there's overlap with some other really common or really popular projects out there like Google's Tink and Amazon's application encryption SDK, we decided to open source our own solution because of our focus on these efforts. Our attitude has been, we're going to provide a new entry and then collaborate with any and all awesome open source projects that are in the same space to see if we can create new opportunities to innovate together, possibly layer the approaches of different libraries that have different use case emphasis and different parts of it that are excellent, and work together with these other groups in order to advance the entire industry so that all enterprises can be safer. Asherah is currently a GoDaddy incubator project. We're testing it actively internally so that we can validate that it fits our use cases, that it really is going to address the problems that our teams have. We want to make sure that it's easy to use for developers. We want to have teams internally testing that out. And then finally, is it really helpful in production? Is it really protecting our keys? Is it really protecting our data? We also want to begin the process of externally auditing this important piece of security software. And so we've already done some design reviews, but we intend to now take that design review to more external vendors, as well as have external audits of the code bases for each of the languages that we intend to provide. We also want to make sure that the library is testable across that language base so that we know for sure and with certainty and confidence that the Java version works the same as the C# version, that we can swap in a Node.js version and have its Metastore and KeyStore implementations work exactly the same on top of the same data that other libraries are using. This guarantees our microservices are interoperable and guarantees that we have flexibility to change the code base when we need to. Finally, we're open sourcing the library so that we can start to get even more feedback. We've already got some internal feedback. We want to get external audits, and we want to reach out to all of you to get your feedback. Help us with the design. Help us with the use cases that we think are most important to address, and come contribute code. So it's an important goal of Asherah that it be easy for developers to use. Now, one of the very first languages that we chose to implement, and we're going to use as this example, is Java. And as a Python developer, I see a lot of lines of code here when in Python probably would only be 2 or 3, but still.
But white space is not important in this
No,
language.
that's true. There's
which is
all
good,
all those curlies though,
just
right?
making sure.
All right.
All right.
But I think even in Java, this idea that the code is very easy to write and use is very impressive. So let's take a quick peek at this code. In the first block of code here, what you see is this builder pattern, where we build the context for a new application encryption session. We're choosing things like picking the keys, choosing our metadata store implementation, choosing our key management service implementation, choosing one of those crypto policies that expresses how in this session keys will or won't be rotated. And then in that context, everything else looks pretty straightforward. We simply take a payload and we can encrypt it. And we take another payload and we decrypt it back out. Now, underneath the covers, that key rotation is guaranteeing that if a key was revoked, it's been replaced, and the data beneath it has been re-encrypted on the fly. This is a very powerful concept. That means that that complication of managing those situations is not in the developer's hands anymore. It's in the hands of the SDK. And we think that that's pretty cool.
All right, so let's have some fun with some use cases. For this first use case, I am going to play the nice guy, white hat, while my evil friend here is going to play the evildoer. First one we're going to talk about, which I think is relatively non-controversial, but it is opinionated in the way we handle things at GoDaddy, is we do not have secrets or credentials in source code ever. Well, ever again. Because I'm pretty sure if I polled even this audience, someone has seen secrets or credentials in a config file that got checked in the source code sooner or later. So in case you haven't seen that, my evil friend here is going to take us through ways that you could take advantage of that if you were evil.
Cool. So I've gotten into your system. I've got your source tree, and I don't see any credentials in it yet, but I'm pretty clever, so I'm going to take a look at your branches, and oh, it does appear as though maybe at one point you might have had some credentials in your source control. Well, I know that there might be something in the Git history here. So what I'm going to do is I'm going to install an open source piece of software called Trufflehog. Trufflehog is an awesome project, and it's designed to scan Git histories for sensitive keys. And by simply running Trufflehog against this pretty vulnerable code base, what I'm immediately going to find are a couple of AWS access keys right here. And so, game over, right? You thought you were safe because you deleted those things out of your Git repo, but it's still in your history, and we pwned you.
All right, so relatively straightforward example. However, the Asherah takes care of this Doesn't take care of it directly for you, but it does speak to a mindset. The mindset starts with the root of the keys are controlled by, at least in AWS, are controlled by IAM access rules. That's the root of the key. That's the only way to get at the root of the key that then starts to unlock this hierarchy of keys. Unlocking that hierarchy of keys means we don't have to worry about the key recursion problem of who stores the root of the key. This then means that we can then hard push on our development team so that they do not store any secrets or credentials in their source code. So for the next one, we're going to talk a little bit about defense in depth. However, we're going to switch, so I get to be the evildoer, and this guy gets to take on the white hat role. Looks better on me, I think.
Yeah, probably. So, I'm the good guy. I'm writing web services. I want to write a web service, for example, that's going to access some third-party API that we use. So I'm going to need some credentials for that. This code pattern that you see here, you'll note it's still Java, so I would have rewritten it, but nevertheless, we've got this.
Because you like white space.
I do love white space.
Okay, that's weird.
Got this code pattern where you've seen this every day. We grab some credentials, we need it for the third-party API call, and we just use it, right? Now, third-party API calls can take a long time at points, or perhaps we don't clean up this key in the appropriate way, but this pattern that you see happens all the time. But it is vulnerable, as we'll now see in some detail.
So this does make the assumption you get access to the box. So bear with us. There's lots of ways of doing this. You could also core dump the process and a few other things. But you load that memory, load that secret from Secrets Manager. You put it in a memory. And if you aren't protecting that memory, I got on a box. I figure out which Java process is running. I go ahead and look at bear with me, the Python code that we had to write for this for a minute, and all that white space indenting stuff you have to deal with. And we look at the proc memory space. We're going to walk the maps, then walk the memory, and we're just going to do simple strings and see if we can't find the API key that we have in there. We go ahead and do that, run a memory scan on that particular process ID, and we're going to sure enough find our AWS secret keys that are sitting in there. As soon as the typing gets a little faster. All right, good. Again, there's lots of ways to accomplish this. You could dump it out as a core dump file and strings the core dump file as well.
So Asherah helps protect against this by use of this secure memory protection library that you see underlying the entire SDK. And right now, we've started with some very basic protections using mprotect and prot none. Later on, there's other innovations that we can add, both in the way that we protect the memory and in the way that we set up the machines, for example, by limiting ptrace scope. So there's various ways that we can help protect against this. And Asherah has those all built in. And because we've abstracted this away into its own memory module, this is a place where we can innovate, changing and improving the library without ever changing the developer experience, because the APIs at the higher levels won't have to change. It's just that the secure memory cache underneath the covers will be more and more secure. So if I were to rewrite this code base, I would then use Asherah. And you see here at the first example, what Asherah does from its session factory is it lets you create a protected memory space into which you load the secret by default. At that point, the secret's secure, and the only moments at which the secret is potentially vulnerable are those moments in which you are accessing them directly for the use of a particular service. And so you have this sort of context manager or with block where inside of that block, you're very conscious that the key is actually being used, but otherwise it's protected in all other parts of memory, and any other keys that are in the secrets manager key cache are protected the entire time. I'm going to give this back to our black hat and see if we're still vulnerable to the same attack.
Excellent. So let's see just how much this Python programmer's frustrated me. So we're going to go ahead and run the same attack that we did last time, but this time on a separate process that actually has some of the basic memory protections we have in place. I stress here that these are pretty basic protections in the incubator project at the moment, and we'll be looking for contributions there, as well as looking at some of those other projects we enumerated earlier and see if we can't leverage some of the ones they have in there as well. So again, we're going to find the new Java process. We're We're then going to go ahead and run our same memory scan, and sure enough, it's not going to be in there. Therefore, frustrating our black hat. Got it.
So the first two use cases that we went through were pretty straightforward. It had to do with a particular initial, maybe naive approach to securing your keys, and then we saw an attack and how Asherah will solve that. This next section is a little bit more subtle and has more to do with our opinionated take on key rotation management and re-encrypting data under the covers, and blast radius reduction for protecting us from the limits of the exposure to a compromise. So Asherah is based on two core concepts: envelope encryption and a hierarchical key structure. Why do we use envelope encryption? Why is envelope encryption important? I think that there's basically two reasons. One is it makes metadata storage easier. If you had to separately store each key and a reference to it in the meta store separately, then you'd have two sources of truth of which keys respond to which data, and so it's not ideal to have to manage both of those and keep those in sync over time. A second reason is that the metadata store has to keep versioning information as you change the keys over time, and that level of complexity is also a lot simpler if you simply store the key material encrypted with the data. In a key hierarchy, using envelope encryption and a metadata store that references a layered key approach limits the blast radius of any particular compromise, and it also provides an opportunity for us to re-encrypt data on the fly in a way that's performant. Because I know, because I have an audit trail of all the key accesses and I know what's potentially compromised, if I know that a particular customer or a particular service has data that's been exposed, I can on demand re-encrypt that data and still do incremental re-encryption on the fly over the course of the rest of the library. I never am in this situation where I have to re-encrypt my entire database, my entire S3 bucket, all of my assets. And you know, I mean, none of us do this, certainly, but imagine if we did only have one key for our billions of records of PII that we're storing. GoDaddy has millions of customers and billions of rows of data. What would happen if that got compromised? I think it would send you right back to 2002, where back in those days we may have been naive and done that, and we realized the key, our one and only one key to rule them all, was compromised, and we had to walk
through and re-encrypt like all 18 million rows. Database be off for a couple hours. Can you imagine how happy our CEO would be about, you know, not being able to take bills or anything like that, or not be able to charge anybody for a few hours? That wouldn't work. That wouldn't work out so well.
Yep, and there's our under construction representing that our shopping cart is offline. Again, the entire rationale and the goal behind Asherah is to prevent that situation from happening, but also to prevent it in a way that is relatively developer neutral. When you have hundreds of teams, as we do at GoDaddy, you can't have each of those teams taking a completely different strategy to this problem. Not only would that prove incompatible as you had teams interacting with each other, but also it's actually a tricky problem and a difficult one to solve and a significant effort to create the solution, and it would be inefficient to do that at scale.
Key rotation in general is a difficult thing to solve, and one of the mantras that we have inside the application service team is if it's hard, do it often. So in our test libraries, those keys are being rotated on every single access. That allows us to make sure that every time we do this, and that way if you keep doing it over and over again, it starts building up in your tests, and you don't have to fear the fact that, because we are trading in complexity, this hierarchical key structure for security. And in introducing that complexity, we need to make sure that we can always recover from it. So that's why, at least in our test libraries, it's rotated on every touch.
So come help us. We've open sourced Asherah. We actually kicked it off today, made it public on our GitHub. So come join in the fun. We are welcoming contributions, both ideas, documentation, code, new languages. We have guidelines to help people get started. please come join us and help out. It's part of our goal here to provide this increased security by getting more and more eyes on it so that we can be not only better as a company, better as an open source contributor, but also improve all enterprises' security posture.
So in conclusion, as Ed just said, our goals here were to make sure that it was easy to do hierarchical key encryption and re-encryption of that data on key rotation. We have an open source, we open sourced it today. I do want to take a moment to first of all thank Ed for leading the team to do this. And second of all, I have 3 members of the team up here that has put in a crap ton of work to get this thing open sourced. So at the end, we're going to take some questions now. If you have questions, feel free to ask. If afterwards you want to talk to somebody, you can talk to either myself or Ed or any of these 3 gentlemen sitting up here. We're open for questions if you guys have any.